Hello and welcome back. My name is Kevin. This is Argument Parsing in Rust version 2. This is episode 6. We're going to be talking about ArgMatches and how to get those values out of our arguments that we defined previously after the parsing is completed. So, if we go back to the documentation, here I have the arg documentation still up. If we look on the left, there's an ArgMatches struct. Now, if you remember from our original demo, we called the getMatches method of the abstract, and that started the parsing process and then returned some matches to us. As you've seen in the previous 5 videos, we keep getting a warning saying, hey, we're not using that matches struct. Well, now we're going to use it. So here, there's quite a few different ways or different things that we can get about our arguments, or so a bunch of information that we can get about the arguments and how they were parsed. We can get values. We can get lossy and OS values, which we'll cover in a later video because those are slightly more advanced. We can determine whether or not an argument's present or not. We can determine how many times it was used. And then we can also see some things about subcommands and their matches. So this is, again, easier to demo live. So we're going to open up our fake program again. And before, we had we had 2 positional arguments. We had arg1 with an index of 1, and then we had arg2, which accepted multiple values. And it's, although not specified, because 2 would be the next index available, it has an index of 2. We just didn't specify it explicitly. But we're going to do that right here just to keep it a little bit less confusing. Now, also, this says this is our first argument. The help text is a little off, so we'll say second argument. And that was only because we copy and pasted. All right, so back to these names right here, arg1 and arg2. We're going to need to remember those because that's how we're going to get the values out of our matches. Let's remove this comment here. All right, so let's first determine whether or not a argument was used. So we're going to take our matches struct, or you know what, let's just say if matches.is present. Now we give it an argument name. We can do the same thing for arg2. Now, because these are index-based ones, it would be a little silly if we used arg2. If we used arg2, we know arg1 was also used because they're index-based. But just for the sake of this simple demo, we're going to show this off. No more warning. All right. First, we look at the help text again. Same thing. All right, let's just do 1 first. arg1 was used. arg2 was used. And remember, arg2 accepts multiples, so we can do all kinds of stuff. And it's not going to complain. All right, so that's somewhat useful. We know whether or not an argument was used. Let's see if we can determine how many times an argument was used. Here we're going to print out how many times it was used. And by using the occurrences of, it will return how many times this argument was used. Now, this is kind of silly for arg1 because it should only be used once, but it should be able to better demo what we've been talking about. Whoops. All right, this actually brings up a good point. I accidentally typed arg3. I just missed the key, fat fingered it. If we were to do this, clap is not going to complain. This is one of the downsides of being stringly typed. It's not going to complain. To keep memory usage low, if an argument was not used or is not valid, it's not kept in memory. So we could say occurrences of arg3, and clap's gonna be like, yep, doesn't exist. That's the exact same as if we didn't even define it up here, because later on, as programs get bigger and you have more and more arguments, keeping a bunch of arguments in memory that were never even used is somewhat of a, it could be bad, right? And I guess in all reality, it doesn't matter as much, but it could. There are ways. If you look at the clap repository, there is a version 3 branch going on that's working on removing this, or not necessarily removing it, but giving you other options other than stringly typed, where clap will complain and say, hey, that argument wasn't even defined. So, all right, arg2 and arg1. Whoops. I actually don't want to quit that. I just want to switch. Again, just out of habit, I'll do that. All right, so arg1, it was used one time. arg2 was used one time. arg2 was used 6 times. Here we have 1, 2, 3, 4, 5, and 6 times. So now we can determine how many times an argument was used, which can also be useful. Think of things like verbosity flags or debugging level flags. Sometimes you'll have programs where you pass the dash lowercase v and it will output verbose information, but maybe you want to support multiple levels of that. So you have dash v, and it'll output even more verbose information. And then maybe you have a third level of extra verbose of dash v, or dash vvv. That's something that some programs support. So now we can know how many times an argument was used. There's also other times where you may want to know, for example, let's say instead of calling this arg2, we'd called it files to work on, or something along those lines. We might want to know how many files the user passed in. So that's why we have an occurrences of. But now for the most useful thing, we have value of. So value of returns an option. If the argument was not used, it will return none. Same thing if the argument was not even defined, it will return none. So that's just something to keep in mind, and be careful with some of these string names. If the value was used and there's a value stored in there, it will return some and then the string value. All values are returned as strings because the user is typing them in as strings. There are ways in clap, which we'll talk about later on, to convert those to actual Rust types using some of the macros defined in clap, but we'll get to those in a later video. If you're curious up front, you can look at some of if we go to the repo and then you go into the examples directory and then you go down to typed values, you can see some of the examples of getting typed values out of clap instead of just strings. All right, so something to be said about these values that are coming out and they return an option. What if a value is required? It's still going to return an option because there's no way to determine whether or not a value was required or not, or there's no way to differentiate between ones that were required and ones that were not. All that means that if it's required, you can probably call unwrap on it instead of doing something like an if let. So here, if we have matches is present, if we were to do this inside here, we could call unwrap on the value of the matches.value of call, because we know it was used. But I'm going to demo another way that's probably a little bit more common, is using if let. So we say if let some, let's call it a1 val equals matches.value of arg1. So now we have a value for it. All right. Notice I didn't do value 2 or arg2. We'll see why in just a second. Arg1 equals 1. We could also use strings. Sum. All right. Let's do this for arg2 and see what happens. What do you think is going to happen when... Oh, I'm sorry. I didn't mean to push that button. When we do this, because arg2 accepts multiples. So let's see. All right, arg2. We're going to do sum and other. All right, it looks good. Sum and other. Let's add some more values to arg2. Still says sum and other. All right. So what's happening here is we called value of. That's only going to give us the first value that that was defined inside there, or that came back. If we want to get all the values, we can use the plural. Values of arg2. What that's going to do is it's going to return an iterator or something that implements iterator, the iterator trait, so that we can actually loop over it and get the values. So now we could say for val in A2, let's call it vals actually. Ooh, I'm sorry, I hit something with my finger. I need to turn on my auto indentation as well. All right. Let's run this. All right, we're going to run this with the same thing. Sum and other, 1, 2, 3, 4. So the values for this should be, sum is for arg1, other 1, 2, 3, 4 should be the values for arg2. Oops, and let's see. There we go. All right, it was used 5 times. The first value was other, and after that it was arg1, 2, 3, and 4. The values are stored in order. So that's because that is important for some applications to get them in order. So if we were to do this 100 times, it should always come back in that same order. If we were to change this, 4 and then 3, we should see 4 and then 3. And sure enough, we do. There's other things that we can do to get more than one value back. You know, we could have called collect and got a created a vector and or a vec and done some other things like that. But that's how we get the values out of an argument, or how we get multiple values out of an argument. All right. Now if we come back in here, I'm going to actually erase some of this for the next one. But next time when we come back, we're going to talk about flags. Finally. I know it's a few videos ago I said we were going to talk about this, but we're finally to it. So now you should have a good idea of how to use all of your positional and free arguments and how to get the values out of those. So again, thank you for watching, and I hope you enjoyed.